Okay, so we are looking at section 9.7. It's on page 274 in your student journal. Okay, so our first functions we're looking at, they're our first identities. A trigonometric identity is just a true statement. You should already know that the reciprocal of cosecant is sine, right? If I know this relationship, if I know cosecant is the reciprocal of sine, meaning it's 1 over sine, what would I know about cosecant theta times sine theta? What would it have to equal? 1. So that's another identity that I could use if I needed to. All right, write down the next one I would know. If I know secant theta equals 1 over cosine, what else would we know? Emma?
That secant times cosine.
Good. Okay, so that would always be a true statement as well. Same thing here. If I know this one, I know cotangent times tangent is 1. But I would also know that tangent is 1 over cotangent. Remember how we can just switch these two? So like I would also know cosine is 1 over secant. See how I can just use all of those in a different way, whatever way is the most useful for my problem. Here's another one you're going to have to know. Tangent, remember how tangent is y over x? So tangent is also sine over cosine. We have to know that. Cotangent, I always remember this because of the co. See how they kind of line up there? So cotangent is going to be the reciprocal, which is cosine over sine. That's another important one. These Pythagorean identities, these can be difficult to memorize, but not if you understand where they come from. I want you to think of the unit circle and a triangle inside of it. If I have this triangle, this hypotenuse would be 1, this would be x, and this would be y. I know from the Pythagorean theorem that what must be true? Right. Or x squared plus y squared must be 1, right? Well, what's another name for x in our unit circle? Cosine. So I know cosine squared theta, here's my theta, cosine squared theta plus sine squared theta, because that's what y is, must be 1. And that's where this identity comes from. For whatever reason, they always turn it around and say sine squared plus cosine squared equals 1, but you could use this one too. Now something else I could use. What if I subtracted sine squared from both sides? What would that mean that cosine squared is equal to? 1 minus sine squared, right? So I can use this or any variation of it when I'm trying to do some identities later. Now, where do these come from? Well, here's what they do. They take this and they divide it first by x squared. What is x squared over x squared? 1. What's another name for y over x? Tangent. What's another name for 1 over x? Secant. And do you see that's where this comes from? Okay. I could use this form of it, but I can use any other form of it as well. What would tangent squared be equal to? Good. Okay. Where do you think this last one comes from? They take that x squared plus y squared equals 1. What do you think they do with it? Yeah, they just divide it by y squared. If we take this and divide it by y squared, look what comes up. X over y, that's going to be cotangent. Y squared over y squared, that's 1. 1 over y squared is cosecant squared. As long as I've taught this, I kind of just naturally have these memorized. But if I forget one of them, all I do is I just do this little trick and I get it as, quickly. So it's not something you really have to memorize. Next, we're going to the co-function identities. These are the ones that I told you always show up on the SAT. This whole concept that the sine of pi over 2 minus theta will have to equal the cosine of theta. Let me just kind of go through that again down here. So let's say that we're told that the cosine of theta is equal to 5/13. We're told that information. And then they ask us, what is the sine of pi over 2 minus theta? If we know this formula, we already know the answer. What is it? 5/13. But let's say we don't. Well, I could draw a picture. I could call this theta. They tell me that the cosine of theta, the adjacent over the hypotenuse, is 5/13. Does anybody know this triple, what this missing side is? 12, good. So they're asking me now to find the sine of pi over 2 minus theta. What's pi over 2? 90 minus theta. If this is theta and this is 90, wouldn't this angle have to be 90 minus theta, or pi over 2 minus theta, if I want to call it that? So now they're asking me to find the sine of pi over 2 minus theta. Here's that angle, opposite over hypotenuse. See how they're always going to be equal like that. Here's another one, another way of looking at it. And then finally this last one. All right, so let's kind of expand this one. So if I told you that the tangent of, let's say, let me think of a good one, 5 pi over 7 has an answer of A. What else would have an answer of A? Hold on, never mind, you can't do 5 pi over 7. It would have to be something that's less than 90, that's over 90. Let's make it 2 pi over 7. Find out what else would have to be A, have an answer of A. It'd be a lot easier if they were supplements rather than complements, but what do I have to do to this, guys, to find out the cotangent of what would also be A? Subtract this from pi over 2, right? So I have to do pi over 2 minus 2 pi over 7, 14, 14, 7 pi, and 4 pi. So what would it be? And so if this were on the actual ACT and I could check it, I could go to my mode, I could make sure I'm in radians, and I could say what is the tangent of 2 pi over 7, that, and then what is the cotangent. To do cotangent, I have to do 1 divided by the tangent of 3 pi over 14. And these should have the same answer, and they do. Anything else I put in here won't work. See, look, let's say that we thought it was 5 pi over 14. Nope, it's not. Okay? All right, so these are some other co-function identities that are helpful to know. The negative angle identities, we talked about these during the warm-ups. When I had you find the sine of pi over 6, and then I had you do the sine of negative pi over 6. Were they equal to each other? No. What did we have to do to this one to make it the same? Multiply it by a negative. So that's why this is saying the sine of negative theta is equal to negative the sine of theta. Okay, and then we'll be using those. All right, so how are we going to use all this? Well, let's go over here. Okay, so part 1, get rid of this problem that's here because we're going to do this one. We've got cosine squared x plus sine squared x all over tangent squared x equals cotangent squared x. What this is this is a problem where they're giving us the answer and we have to prove that that answer is correct. Okay? Proof, a lot of people are like, oh my gosh, are we doing proofs again? Well, it's not really a true proof because you don't have to tell the reason for everything you do. You just have to do it. So what we're trying to do is make this side equal that easier side. So what is another name for cosine squared x plus sine squared x? 1. So I would now replace that with 1 over tangent squared x. I just work with one side, never both sides, just one side. Now what's another name for 1 over tangent squared x? Cotangent squared x. And we are finished that quickly. Check. All right? Just trying to prove it. This is easy because we know what the answer should be, right? We already know the answer. We just have to make it work. Okay, a little bit tougher here. We have 2 terms, and we have to get it down to just one term of tangent. What do you usually do if you have 2 fractions and you want to put them together and create one value? You get a common denominator, don't you? Also known as the least common factor is correct for the denominator. So what would I have to use for a common denominator? If I have 1/2 plus 1/3, what's my common denominator? What do I do with the 2 and the 3? So what am I going to do with these 2? Multiply them. So my common denominator is going to have to be sine x cosine x for both of those. That's my only choice for the common denominator. So what do I have to multiply this by then to get that common denominator? Sine x. So I'm going to multiply this by sine x on top, sine x on bottom. What is sine x times cosecant x? Good. So I'm going to have a 1 on the top. Minus. What am I going to multiply this by? Cosine x on bottom, cosine x on top. So what is cosine times cosine? Cosine squared x. By the way, why do you think that they don't have us write that like this? When I multiply cosine times cosine, they never write it like that. Yeah, you think the x is squared, but it's not. It's the whole cosine of x that's squared. It means something different. All right, so now we have a common denominator. So now we have 1 minus cosine squared all over sine x cosine x. Well, do we have another name for 1 minus cosine squared x? If we look at that other page, can we come up with one? If we go to this identity, 1 minus cosine squared x, sine squared. So I want to replace this. Now see, I can go this way too. I don't have to just go down. So that's sine squared x over sine x cosine x. Sine squared x means sine x times sine x over sine x times cosine x. So what can I do? Get rid of a sine x, right? One goes away on top. That one goes away on bottom. So now what I'm left with is sine x over cosine x. And what am I trying to get it equal to? Tangent. And there I go. There's the tangent. Check. We got it. Now, if we had more room, we really just would have kept this all going vertically. But I don't care. We had to kind of wrap around there. All right. We're going to go down here now. We're going to do these later. Let's go down here to this one. So we're trying to prove that this is equal to that. Any ideas on what we should do? Yeah, you guys don't have this part, so just add that on. Or maybe you do have it. I don't know. How are we going to make them equal? Is there any replacement I can do for tan theta? Sine theta over cosine theta. So what I've got then is I've got negative sine theta over cosine theta. And that's all over. Now I should go ahead and get another name for secant while I'm at it. 1 over cosine theta. So I have a complex fraction. Do you remember how we can simplify a complex fraction? I can either multiply by the reciprocal, or I can just multiply the top and bottom by cosine. Whatever you like. It's the same. So now these cancel, and see how we're finished? Just that easily. And a lot of times when you first learn this, it's kind of like, how do you know to do all that? It kind of just seems like a mystery. But it's like, if I'm trying to get an answer of sine, I want to come up with names for these that have sine or cosine in them, right? Because that's the only way I'm going to be able to get it to go down to just a sine. All right. What do you think about this one? This is the one I told you is so important to know. Is it sine of something, or is it sine of what? Right, so it's going to be sine theta. Look at what we're trying to get to. We're trying to get to sine cubed. So we want to have sine times sine times sine. So any ideas on this? That's sine squared, isn't it? All right, so that's wonderful. Because we now have sine theta times sine theta times sine theta, and that is exactly what we needed. So this is the best notation right here, is writing that equals that, check, done. All right, we're going to get a little bit more complicated. Flip over. Number 7. All right, what about on this one now? Can you see anything that we can do here? We really don't want to have a coefficient at first. So anytime I have a coefficient, I'm going to factor it out. I'm going to go ahead and factor out that 2. And while I'm at it, in this denominator, I know that I really don't want it because I want to go down to just one value. So is there another name for tan of negative x? I don't want to make it more complicated, though, so something easier. Looking at our list, tan of negative x. Do you see how it's negative? See how tan of negative x is negative tan x? That's the one I want to replace. So I'm just going to make this negative tan x. Okay, and what's cosine of negative x go to? Negative cosine of x. And maybe that doesn't seem like a big help, but it is going to be here in just a few minutes. Okay, so I've got a 2. I'm going to keep that 2. I need to know another name for secant squared minus tangent squared. Can we manipulate this and get secant squared minus tangent squared? Everybody see why it's 1? Okay, so then this is going to be 2 times 1. All right. And then on the bottom, we have negative tangent times negative cosine. So a negative times a negative is going to give us a positive. Now, any ideas on what I should change this tangent to? Right. Actually, I think you guys lied to me on this one. Cosine of negative theta is not negative cosine. It's positive. Because I'm visualizing that, like the cosine of negative 30 is the same as the cosine of positive 30. That should be a positive. I'm just thinking ahead, too, that I'm supposed to get a negative here. So, yeah. All right, anyway, just flip that real quick to a positive. Okay, so now I've got negative tangent. Oh, I don't want to write that, though. How can I get rid of this? Like, what's another name for tangent where I could get it to cancel with that cosine? So this is going to be negative.
Pardon the interruption. Staff, all seniors should be back at this point from the grade of graduate. If you have any seniors not in your class that were on the that were absent today, please shoot us an email.
So what's going to happen now?
Also, you may have a handful that didn't get lunch because they both got back late. Please be flexible if need be.
So now the cosines can cancel.
Always go by.
And so now, if those cosines cancel, we're just going to get negative 2 over sine x. Is this what your problem said originally or not? Did you guys have that in your book? Okay, well, I think I had a little mistake here then, because this should actually equal negative 2 cosecant x, right? Isn't that what we're going to get? Yeah. So this is going to be equal to, do you see why this would be negative 2 cosecant x? So the problem, I typed it up wrong. It should have been negative 2 cosecant x there. Yeah, darn. Okay, you get the idea though with that? All right, let's go up here now. So you guys have all this, right? But it equals negative 1? Okay. So we're just going to look at the sine of pi over 2 minus theta. Do you remember another name for that? Cosine theta. And I'm going to keep that negative there. So it's negative cosine theta. You always want to get rid of that kind of thing. And then it's over, and then what's another name for secant of negative theta? Think of cosine. Cosine of negative theta, is that the same as the cosine of positive theta? It is. So this is going to just stay as secant theta. And then I have minus sine squared theta. I want to think of another name for this. What's another name for secant? 1 over cosine. So now I have negative cosine, and then I have over 1 over cosine. So I'm going to have to multiply by cosine theta here, and multiply by cosine theta here. So those are going to cancel. So now I've got negative cosine squared theta minus sine squared theta. I want to make it equal negative 1. So what would I do with this? How can I show this equals negative 1? Factor out a negative 1, good. And then I'm left with cosine squared theta plus sine squared theta. And what's that going to be? 1. So I have negative 1 times positive 1, and that's negative 1. And that worked. All right, let's just do one more of these. We've done quite a few. Let's do this one. This one's harder. Here's a big clue on this, guys. It is always difficult to get a fraction like this. It's difficult to make this turn into this one. So anytime I see like two values in the denominator like that, I'm going to work with this side instead of that side. We can work with either side. Now, a big thing that I know is that 1 minus cosine squared is what? Sine squared, right? So that's what I would like to turn this into, is 1 minus cosine squared. Can you think of what I could multiply it by to get 1 minus cosine squared? You got it. It's called the conjugate. In fact, you always do that. You multiply by that conjugate, and it'll get you what you need. All right, so when you do that conjugate, I don't know if you remember this, but you don't multiply out the top. You just leave it factored. But on the bottom, I am going to multiply it out. So 1 times 1 is 1. Outers and inners cancel. Minus cosine squared. What is 1 minus cosine squared? Sine squared. So I'm going to have sine squared on the bottom. Oops, I keep using theta instead of x. And then on the top, I have sine x times 1 plus cosine x. And so what's going to cancel there? Sine with one of these. So now I have 1 plus cosine x over sine x. Anybody know how I can make that look like this one now? I'm almost there. Guys, think about this. If I have 1 plus 2 over 3, am I allowed to think of that as 1/3 plus 2/3? It's the same thing, isn't it? So if I have 1 plus cosine x over sine x, what do you think we should do? And what's another name for 1 over sine? And this one? Cotangent. And that's what we wanted. Check. Okay? Does it make sense? And I'll just give you a hint here real quick on this one. Just what are you going to replace that with? Sine squared. Secant squared is 1 over cosine squared. I'm going to go through this one quickly. I can't stand to leave it undone. So we're going to do cosine squared here, cosine squared here. So now I'm going to have sine squared, cosine squared, minus sine squared. Right here, can you see what I can do? I can factor out a sine squared, and I'm left with cosine squared minus 1. What's another name for cosine squared minus 1? Got to check. A little bit tricky on this. Cosine squared minus 1 is not sine squared. It's actually going to be negative sine squared. So I'm going to have sine squared theta times negative sine squared theta, and that gives me the negative sine to the 4th. So these, I really, we were talking about this at lunch. One of the math teachers was saying, oh my gosh, those identities, those verifying, it's so difficult. And I'm like, I actually think it's fun because, like, you know what the answer is, and it's just like you just keep substituting until you get it to work out. So think of it like that. Think of it as a puzzle that you're just trying to, you know the answer, you're just trying to get there. We'll finish up the rest for the second part.